Hello, this is Ms. DB. In this video we are going to look at how to solve a couple problems from the Systems of Equations Applications Problems worksheet. So our objective is to solve real-world problems involving systems of equations. The directions are important. You only have to solve 6 of the following problems, so you can skip a couple. You have to show all your work. You must write 2 equations except for 1 and 8, which have the equations written for you. For all of the other ones, you have to write 2 separate equations, and then you're going to solve either with substitution or you can use elimination with addition. Both of those methods you learned earlier in this folder. So you should have completed those assignments first. And you can get extra credit if you complete more than 6 problems. So number 1 says the sum of 2 numbers is 70. Sum means to add. So I already wrote this equation for you. If I call one number x and one number y, the sum means to add them together, x plus y, to get the sum of 70. They differ by 11. Difference is subtracting. So I did x minus y equals 11. Now you can, if you choose to do this one, solve this system either with substitution or elimination with addition and find what x and y are equal to. And then you should check your answers and make sure that you get 70 when you add them and 11 when you subtract them. Number 2 is almost exactly like number 1 with different sums and a different difference. So you're going to solve it almost the same way, so follow these steps to do that. Let's look at number 3. The Brastad family is deciding between 2 lawn care services. Tucker Lawn charges a $49 startup fee plus $29 a month. Owen Team charges a $25 startup fee plus $37 per month. So we're going to write an equation for each lawn care service company. Use y for the total cost and x for the number of months. And I set up a template for each. The total cost, y, will equal the startup fee plus the monthly charge times x. So you're going to do that for each of these, for Tucker and for Owen. Those are the names of my 2 oldest kids, by the way. And plug in the right parts, and then you will have a system of equations. Then you're going to solve the system of equations with substitution to find when the cost would be the same. So once you write your 2 equations, they're both equal to y. So for example, for the first equation, let me fill that one in. That would be 49 plus 29 a month. Your first equation, y, is equal to 49 plus 29x. That's what y is equal to. So when you solve with substitution, you can take what y is equal to and replace it for y in the second equation, and then you'll have to look up what the Owen equation would be, and the 2 equations would be put together in that way. So y is 49 plus 29x, so when you see y in the second equation, you can replace it with that. And then you'll have to solve that equation for x. Once you find out what x is, you can plug that back into either of your 2 original equations to find what y is, and then answer question C. Let's look at this geometry question number 4. A ray cuts a line forming 2 angles. All lines are equal to 180 degrees, so the sum of the 2 angles is 180. Now we just talked about the sum. The sum means to add them together, and it says the sum of the 2 angles is 180. So that's one of my equations. Then it says the difference between the 2 angles is 18. And we know the difference is subtraction. So now you have your 2 equations, and you're able to use either elimination or substitution in order to solve this system. This is really set up to use elimination by addition. We could add these 2 equations together, and very quickly, 1x plus 1x is 2x. The y's cancel. We could very quickly find what x is equal to. And then once you find x, you need to take that value and plug it back into one of your original equations to figure out what y is. And I wanted to show you number 8. Number 8 is a mixture problem, which is a very common problem that you'll see in algebra books. It says that a chemistry experiment calls for 1 liter of sulfuric acid at a 15% concentration, but the supply room only stocks sulfuric acid in concentrations of 10% and 35%. How many liters of each should be mixed to give the acid needed for the experiment? So we're going to let A equal the 10% acid and B equal the 35%. So our first equation is just the amount that we need total. We need A plus B equals 1 liter. So just A plus B equals 1. That's one of our equations. The second equation has to do with percentage. When you work with percentages, you always change them to decimals, and then you multiply them by some number or by a variable. So in this case, we need the 10% would be 0.10 or 0.1 of A, because we're calling the 10% solution A, and then we need to add to that the 35%, so that's 0.35 times B, and that will equal the amount that we need, which is the 15% concentration of 1 liter. We know that's 1 liter. So our two systems of equations are right here. Now they look kind of weird, so I'm going to go ahead and for the top one put 1A plus 1B equals 1, so there's some numbers there. And then the bottom one is, you can write 0.1 if you prefer, but I'm just going to leave it as 0.1A plus 0.35B equals 0.15. So this one I think I would rather solve with substitution. So I'm going to solve the top equation for A. A plus B equals 1, so if I subtract B, I get A equals 1 minus B, or you could write A equals 1 minus 1B if you like the 1 in front of it. And I'm going to give myself a little more room here. Alright, so A is equal to 1 minus B. So whenever I see an A in the other equation, I can replace it with 1 minus B. So here's my other equation. Right there's the A. So I have now 0.1 times A, but A is 1 minus B, plus 0.35 times B is equal to 0.15. Alright, so now I'm going to keep solving this equation. It's a little bit of a trickier one. 0.1 times 1, I have to do the distributive property, is 0.1. Anything times 1 is itself. And then I have to do 0.1 times B, so that'd be minus 0.1B plus 0.35B, just write everything else down. Okay, now we keep solving. We have two B's, so we can combine our like terms. What is negative 0.1B plus 0.35B? Let's check that one on a calculator. So we have 0.1, except it's negative 0.1 plus 0.35, 0.25. So we have this 0.1 gets written down again, 0.1 plus 0.25b equals 0.15. At this point, I'm really tired of all these decimals, so I'm going to do something I should have done probably way at the beginning. I'm going to multiply both sides by 100. I'm worried that I'm going to lose one of my decimal points in here. If I multiply 100 times 0.1, what do you think you get? 100 times 0.1 is 10. That's a much nicer answer. And 100 times 0.25 is 25. And 0.15 times 100 is 15. So at any point I should have stopped and said, let's just multiply everything by 100 and that will get rid of all of our decimals, and this will be a much easier problem to finish. So now I subtracted 10 from both sides. 25b equals 15 minus 10 is 5, divided by 25, and b is equal to 1/5, or that's the same as 0.2. This is liters. And now I can find a, because remember, a plus b was equal to 1. So if b is 1/5, and together they equal 1, then a must be 4/5. So a is 4/5 and b is 1/5, or you can use the decimals 0.2 and 0.8. You don't really need to do an ordered pair for this one because it's not a point, it's not x and y, it's amounts of the liters. So for C, you would make sure that you put your units on here and you said how much of each one you would need, how many liters of each. And number 9 is just like that last one, so you can follow along with those methods to do that problem. You can also look in your book for this one. There's one like this one in your book, very, very similar. Or maybe even the same, I don't know. All right, remember you need to pick 6 problems. You need to write your equations unless they were given for you, which they were in 2 problems, and you need to show all your work. If you don't show your work, you won't get very many points on the assignment. Thank you very much and have